Welcome back to Mr. Kleinian Productions. This is a new unit called Stoichiometry. Stoichiometry is a word that it's kind of an ugly word coming from German, but basically it means measure of elements. And a lot of times you need to know measuring elements. Like, for example, I have this sample of carbon, and I could ask a question of this sample: with this amount of carbon, how much carbon dioxide could I make in terms of liters or grams? Or I could say, I have a bunch of carbon dioxide. How much carbon would be needed to make a certain amount of carbon dioxide? So see, stoichiometry is about measuring things so you can get the right amounts. How much something can I make if I have something else? So if I have a certain number of grams of reactant, how many grams of product can I make? Or conversely, how much reactant do I need to make a certain number of grams of product? So this topic is called stoichiometry. So a very simple example of a stoichiometry problem would be like for cooking. Let's say you have a recipe for making s'mores, which is 2 graham crackers, 1 marshmallow, 1 piece of chocolate. Graham crackers symbolize GC, marshmallows symbolize M, chocolate symbolize C. Write out a chemical equation for making s'mores. Okay, so this is like a chemical reaction combining things together to make a product. So what I've done is I've written out a chemical reaction for making s'mores, and you see how the symbols work here. 2 graham crackers plus 1 marshmallow plus 1 piece of chocolate will make 1 s'more. So the coefficient here becomes a subscript here, and you're making one thing out of basically 3 different ingredients, which I've symbolized right here. So 2 graham crackers, 1 marshmallow, 1 chocolate makes 1 combined s'more. Okay, now from this information, we can basically see that if we have a certain amount of graham crackers, we can figure out how many marshmallows we need and how many pieces of chocolate do we need to make a certain number of s'mores. So this is the type of question that you might see. What if, for example, I have 15 graham crackers? The question could be, how many s'mores could be made? And so it's a rather easy question. And of course, to get at the answer of this, you have to look at the ratio of pieces. So since we have 2 pieces of this, 1 piece of that, 1 piece of that, 1 piece of that, you could go ahead and figure it out, given the fact that it's 2 graham crackers to make 1 s'more. Now, one thing I want to introduce early on in this is that in chemistry, these numbers in front, called coefficients, there's a unit in chemistry called the mole, and these coefficients are in that unit of mole. Now, we don't use moles cooking, but I could read this equation: 2 moles of graham crackers react with 1 mole of marshmallows and 1 mole of chocolate to make 1 s'more. Now, the real important step in stoichiometry that starts things out is this middle step that relates one thing to another thing. Now, this step is called the mole ratio. And the mole ratio is having to do with these numbers 2, 1, 1, and 1. What it's trying to tell you is if you have 15 graham crackers, you're going to need to divide that number by 2 to get the number of s'mores. You can see it because it's a 2 to 1. So the ratio then, mole ratio in this case, would be 2 graham crackers make 1 s'more. And this is what we would call in chemistry a mole ratio. Given a certain amount of ingredient, given the recipe here, because this is the recipe based on our chemical equation, we could figure out how many s'mores we could make. Of course, the math is very simple. 15 divided by 2 would be 7.5 s'mores. Of course, what good is a half a s'more? But in chemistry, you can have decimal amounts like this. It doesn't have to be a whole number. So what if, for example, I give a problem to you like this, where you want to make 20 s'mores? How many graham crackers would you need to make the 20 s'mores? Of course, you see that it's a 1 to 2 ratio. So right here, we put in our so-called mole ratio, and I want to cancel the unit of s'more down here. So I'm going to put GC2 MC, and then here I'm going to take this number and bring it down here, and then the number that I'm looking for over here, I'll take that number and put it in front. So here's my ratio of 1 s'more is 2 graham crackers. And of course, this is how you set up chemical problems. The unit of s'more will cancel. So it's quite obvious that in order to get 20 s'mores, we're going to need 40 graham cracker pieces. So notice in this case you've got this mole ratio. There are a number of different mole ratios depending on the problem. You could ask the same question, given a certain number of marshmallows, how many pieces of chocolate will I need, a 1-to-1 ratio, or how many pieces of chocolate will I need to make 100 s'mores? Or there's all kinds of problems. But the first thing in chemistry is to learn about this important ratio. Again, this is called the mole ratio. And the whole reason for talking about this problem with s'mores isn't about making s'mores. It's about learning about this ratio right here. Okay, let's try a beginning chemistry problem then. This is a nice little problem to start thinking about. Sodium metal, solid, reacts with oxygen gas to make sodium oxide. And of course, before we actually get to the problem here, which is the mole ratio problem, let's take another look at this formula to see if everything is okay. Sodium is a metal, metallic bonding, and it should have a subscript of 1. Oxygen is O2. And then this actually is written incorrectly because when you combine sodium and oxygen together, now they have an ionic bond. This is a metallic bond, this covalent bond, this is an ionic bond, which means that the sodium and the oxygen take on ionic charges as the sodium gives electrons to the oxygen. Okay. Well, now we need to balance this little formula here. Since this is +1, I'm going to need 2 of these. That makes it +2 total to balance 1 oxygen minus 2. And then you always erase these in your formula. Okay, so now I have the correct little formulas for sure. I've double-checked them. Now I need to balance the chemical equation. Because I have 2 oxygens on this side and 1 oxygen on this side, I really need to put a 2 here. Okay, now I have 2 oxygens and 2 oxygens. Now I have 2 times 2 are 4 sodiums, so I need to put a 4 in front here. Now it doesn't have to be written, but because we're talking about mole ratios, I'll put a 1 in front of there to show that it's going to be a 4 to 1 to 2 ratio here. Now again, a reminder that this number in front is actually in units of moles. So I'm going to put that right here to clarify that again for you. So any chemical reaction could theoretically be written and said like this: 4 moles of this reactant react with 1 mole of this reactant to make 2 moles of this product. Okay, so now given that, let's go ahead and work out this problem. In any of these stoichiometry problems, you have a given number here. Now that number has nothing to do with any of the numbers up here, but that's just a given number that I could have been any kind of number. I just made this problem up. I said 6.9 moles of sodium. How many moles of oxygen will be needed? Okay, now to set this up, first of all, put the 6.9 moles of sodium, I put it over 1 to show that it's the numerator, and be sure you're complete in putting all the units and the substances and everything out here so you don't later get confused. Now I need to put in the mole ratio, which would be, in this case, it's going to be 4 sodiums will make 4 sodiums, I need 1 oxygen to the 4 sodiums. Okay, so I'm looking at my answer. My answer is going to oxygen here. So I need to cancel this unit and this substance, so I'll put this unit and substance down here. These are always going to agree exactly, but the number here is the number I'm going to take from right here, 4. Now this right here will be what is my answer, which is going to be how many moles of oxygen. So how many moles of oxygen? I need to put this right here, moles of oxygen. And the number that goes in front of that is the number I'm taking right from the chemical equation here. Okay. So essentially, to answer this problem, all I need to do now is do a math problem. 6.9 divided by 4 is equal to the number of moles of oxygen that I need. So doing the calculation, I have 6.9 divided by 4 is 1.7 moles of oxygen. So this is the first very simple stoichiometry problem, emphasizing this piece right here, which is in every one of these problems. It's called the mole ratio. Another problem. So I have a chemical equation here. The question is, how many moles of ammonia, NH3, can be made from 15 moles of hydrogen gas? Maybe you could pause the movie right now and solve that. Well, let's see if you got it right. So first of all, make sure you balance the chemical equation, making sure all the formulas are correct again. I'm looking at them, they're all good. So balancing this chemical equation, I notice I have 2 nitrogens and 1. So I'm going to put a 2 in front, giving me 6 hydrogens, 2 times 3. So I need a 3 in front here. And of course, this is a 1. Now from these numbers, I'm going to get my mole ratio, 3, 1, and 2. As if to say, 3 moles of hydrogen react with 1 mole of nitrogen to make 2 moles of ammonia gas. Okay, so now like the last problem we saw, what you can do is, first of all, identify where the starting number is here, some number that I just gave you to start the problem. You'll notice that it's the 15 moles of hydrogen gas. So this is a sort of a given amount here. If ever I refer to a given amount, it's the problem in the it's the number in the problem that's only there because you have to start with some amount. Okay, starting with that, I start out with 15 moles of hydrogen gas. So go ahead and write it all in there. Don't leave it out. And then I go ahead and figure out where I'm going, keeps me oriented. How many moles of ammonia? Okay, so how many moles of ammonia can I make given 15 moles of hydrogen gas? Now again, I need to convert from moles of reactant to moles of product, meaning this is going to again be what's called the mole to mole ratio. In the bottom, I want to cancel the given, which is the hydrogen, and in the top, I want to make the unit of ammonia. So then you have a number to put here, number to put here. No mystery where those numbers are coming from. They're coming from the coefficients in the balanced chemical equation. So as you can see, 3 is going with hydrogen. 3 is with hydrogen. Ammonia, the number going with ammonia is 2. And so to solve this problem, I'm going to need to take 15 and multiply by 2 and divide by 3. Now doing the math, 15 times 2 equals, divide by 3 equals, I am going to be able to make 10 moles of ammonia from 15 moles of hydrogen. So here's another example of this critical step of having a certain number of moles of reactant or given, shall I say, and making a certain number of moles of what we're looking for, which is, in this problem, the ammonia. This step right here, again, is the mole ratio step. That step is in every problem, so if you don't have that step in there, you're doing something wrong.